Hi, I'm Sunday Sylvester NASA, and today in this video I'm going to discuss some equations of motion. So I'll be based on Jamb questions and answer. So I'm going to go through this topic typically of calculations there. I'm not going to discuss much about the theory or the calculation part because most of the question in this topic is actual calculation. They're very simple. So all you need in this topic is just how to bring out your data out. Because once you know how to bring out data, to know the formula is not something hard. And if you have problem with forgetting the formula, well, you can be repeating it when you learn it. Well, make sure every day in the morning, every day if you wake up in the morning, you try to recall it by writing them down. That's how you do. The more you keep doing it, you start giving yourself time. Like after you've been doing it, like you have not felt in it, you can shift it to like after 3 days. Next, you shift it after a week before you realize that you will never forget it. I've some bosses like this. I don't think there are some people that will ever forget those equations of motion because they are very simple. The equations have become part of them. So repeating will help you that. So I'm not going to waste my time on how to learn the equation, or if you have problem with the equation is just to cram them or to know them. That's all. So this lesson today I'm going to focus on how to bring out data and how to know which equation to use, because once you know this ones, the rest is just maths you're going to solve. If you have calculator, you punch your calculator fast and get your answer. So that's cool. So first we have three equations of motion. They're actually four in number, but most of the time they used to go with the three, because if you know the three you can calculate anything. It's just that sometimes you have to use two equations, but if you know the four, instead of using two equations in some question, you can use only one equation for that. So that's what I'm trying to say. But if you don't want to stress your brain, you can go with the three only. No doubt there. It's all the same thing. Nobody will fail you. But for example purpose, I think the fourth one is not something hard also. You can grab it. So at first, the first one is actually derived from the definition of acceleration here. You already know that acceleration is change in velocity over time there, right? It's change in velocity over change in time. I know when you measure change in time, when I say change in time, it's just the time between them, right? Because time always starts at zero. So change in velocity is just final velocity minus initial, while the change in time is just time there. So neglecting this one, we have acceleration is equals to v minus u all over t. So if you cross multiply, you have v is equals to u plus at there, right? I've taken the u to this side, so it has turned to plus at. I don't have time to doing all of those maths there. So this is a very good starting equation for all equations of motion. It's basic ones there, right? V is equals to u plus at. Actually, it cannot be plus or minus because sometimes acceleration is negative. Like you have deceleration, sometimes called retardation. So it's actually negative. It's plus or minus. So you watch up there, right? There's some question that you have to use negative, there's some question you have to use positive. So most of them you use positive, but there are some of them that you use negative. I think I have question under them. We're going to work on them also. So in all we're going to be doing today, we'll be using some terms there, right? First we'll be using initial velocity as u. Don't know where they get the say we should use initial velocity as u, because if you spell the word initial velocity, I don't think you have something u that is interesting there. But I don't know why they're using, but it's common to everybody. Why the final velocity is v, velocity v is cool for you. So this is the initial and this is the final. While the acceleration is denoted by a and the time is denoted by t, and the distance is actually in s, not in d there, right? Sometimes you put d, but in motion we use s for distance there, right? So here you have this guy's theorem. So in a question, if they say, uh, first I'm trying to bring out how to bring out data still, right? So if you're reading question and they say something start from rest, you meet a lot of questions that involve this kind of case there. So you have to put in back of your brain or back of your mind. Why? So if you say something start from rest, actually the mean u is equal to 0. Let's say a boy start from rest and move immediately read that thing. Please quickly write your data as u equals to 0. Don't skip it. Don't say it's just a word because you have not seen. They didn't say it start from initial velocity 0. If they just say that word start from rest, it's actually good data. So write u equals to 0. I want at first you should be writing all of the data out so that you know the formula to use. The more you keep practicing, the more it become easy for you. So when they say something start from rest, they actually mean that thing is 0. And again, also if they say a word, they say they mention the question and they say it comes to rest. That means the final velocity now is 0. So you quickly write v equals to 0. Start from rest, acceleration 0, comes to rest, final velocity 0. So these are also good English to know. And again, you have some question that they will not say start from rest, most especially free fall. You know, when you drop something, it actually starts from 0. From your hand, you drop it. Start from 0, where your hand leave it before it starts falling. So when they say a ball, a ball was dropped there right from a certain height, they mean the initial velocity there is 0. Nobody will tell you start from 0, but they say if they say something is dropped or a mango dropped from a tree, when they didn't push the mango, they didn't throw the mango, they actually dropped the mango. So the initial velocity is 0 for that. Thank you for that. And other quantities are very easy to graph, especially for acceleration. Give you acceleration in some of your equation. Sometimes people, if it is retardation, they use the word r for it, the symbol r for it, but never mind. Just that if you're giving retardation, should just be in negative, right, in negative form. All will give you the same answer. You don't need to be changing it to r. So that's cool. So now let's go to the question because I have a lot of questions. Let's go and start picking them one after the other. We're doing it so you can see how simple the topic is. So let's start. Let's start with this. This is not actually part of a question of motion, but a very good starting point from the word acceleration that we define. We say acceleration is change in velocity over time. Change in velocity over change of time. So you have your change in velocity is actually final velocity minus the initial velocity. Let me write it in terms of v in u all over any final time minus initial time. Here is actually in a graph, they pick it up, right? That's why you have initial time, like somebody is moving and they come to pass your house and you read what happened as it passed your house. Actually, it's actually moving. So it's spending a time since. So now you want to cut it off just the fence of your house. So you measure just the time it comes with. Start from your fence of your house to the one that ends with it here, right? So what I'm trying to say is that just this velocity time graph is that you cut this event in the middle of the motion. That's why you have any final velocity time and initial time there. So without waste of time, actually the final velocity is actually 35. The initial velocity was actually 15. Final time is actually 20, or the initial time is actually 10. So you're left with 20 divided by 10, which is just equals to 2. So acceleration is 2 meters per second square. That makes option D correct. So this question is actually very simple without waste of time. Let's go to the next question. So here we're going to enter our real topic I want to discuss here. So look at this. Let's say a car moves with an initial velocity of let's say initial velocity, that's our u, is what, 25. I'm not going to be writing the unit, I'm sorry, because it will stress me, so I'm just going to skip them. 25 meter per second and a velocity of, when I need to convert, I'll convert, but I'm not going to be writing the unit because, as I said, it stress me here, right? So the final velocity is 45 meter per second. So it reached this final velocity in a time of 10 seconds. So if you are asked to calculate, let me remove the seconds there, you're asked to calculate the acceleration of the car. Well, you can use your v is equals to u plus a t, because there is no s here, right? There is no distance here. So now you have that v is 45 minus 25 plus 10 a there, right? Because acceleration is 10 and time is 10 there. So if you take 25 to the other side, you have 45 minus 25, which give you 20 is equals to 10 a. So your a now equals to 2 meter per second also. That makes option A correct answer. So you can see how I use this equation to get my answer fast. So now here you see how I use this equation. So there are other equations that are very important that you should know there, right? So the other equation is that apart from v is equals to u plus at, you also have others there, right? The next is actually s is equals to ut plus or minus half a t square. You also have v square is equals to u square plus 2as, and these are the three good equations that if you know you're done. But if you don't want to be stressing yourself in exam, you can learn also this one because it will be a shortcut for you in some cases. Half v plus u close bracket t is actually plus. So these are the equation. So when you were given v, u, a and t without s, so this when you don't have s, you can use that equation. And if you're not given v, you can use this equation. If you're not given t, you can use this equation. Or if you're not given acceleration, you can use this equation. So that's how the thing works. So you write up your data and check which one you're not given. Then you check the equation that it can work when the thing is not there. So that's good. See that formal question that we solve as time distance is not there, so I was able to use it perfectly without any delay. So that's cool. So let's go for more questions so you can see how the thing is applied. Okay, so now you have this question. They say a body accelerates uniformly from rest. So you can see they have already mentioned it from rest, as our initial velocity is 0. So at the rate of 3, that's the acceleration, the uniform acceleration is at the rate of 3 meter per second square, not per second here, I made mistake here. So in the time of 8 seconds. 8 seconds. So you should now calculate the distance covered during this acceleration. That's what you are to calculate the distance covered during this calculation. And what's now not given? V is not given. So which equation you can use when V is not given? Well, actually, it's just the long one there. S is equals to ut plus half at squared, right? So you have S is equals to u is actually 0 multiplied by t is 8 plus now half multiplied by a is 3, then t is 8 and square. So here you have this place will be all 0 plus, well, I'm not having calculator, so we manage this there, right? So here is actually 8 times 8, which is 8 times 8. Here you have 4 times 2 times 8, and you'll have times 3 there divided by this 2 there. So this will go with this, and the 3 will multiply by this to get 12, and you're left with 8 there. So 8 multiplied by 12. So here you have 16, 6 carrying 1, 8 times 1 is 9, and then you get 9. So you have 96 as it here, because if you add 96 plus 0, it's going to give you 796. Alright, you can use your calculator to do this thing because it's very easy. Sorry for that. You can use your calculator to get those ones there, right? It's very easy. Just half multiplied by 3 multiplied by 8 squared, you're going to get 96. That makes option A the correct answer for ease. So now let's go to next. You can see how I use data and know the equation to use, because that's the main thing in this topic. Know how to remove your data. Knowing the equation is easy, and the math is also easy. Starting in this equation. So another one is that a particle starts from rest and moves with a constant acceleration. So start with rest. So quickly write our u is equals to 0 as usual, and quick accelerate with constant acceleration of that there, right? So you also have acceleration today as 0.5. Calculate now the time taken for a particle to cover a distance of this. So now instead of asking us to calculate the distance, they give us the time and the distance, and they're asking us to calculate the time, and we're still lacking v, so we're using that same equation there. Equals to ut plus half at squared. So you have distance, which is 25. Now put the value 25 is equals to u, which is 0 multiplied by the time there you're looking for 8 plus half multiplied by the 0.5 multiplied by the time squared. So you're left with 25 is equals to 0 plus this is actually 1 divided by 2. So you're left with 1 divided by 4 all here, right? And this t is at the top, so t squared divided by 4. So this is actually nothing. So if you cross multiply, you have t squared is equals to 25 multiplied by 4. If you take square root of both sides, you have t will be equals to 5 multiplied by 2, which is equals to 10 there, right? Which is equals to 10 there. So that makes option C the best answer there, right? So you can use your calculator to work this thing out fast. Not having calculator, as I have to follow it like this. And if you don't have calculator, it's good to be breaking it down gradually like this also to make your work easier there. So now let's go to the next question. So the next we're given a body starts from rest again. I don't know why these people like rest. Start from rest and move with a uniform acceleration of 6. What was the distance cover during the 30 seconds? No, actually I don't like this question because it's going to be long here, right? But let's just solve it. But I don't really like it, but let's just solve it. Or let's do it. We'll do it in the next video or some days here, right? because this thing needs a lot of explanation there, right? Although there's a simple formula that will help you do it fast. So let's just keep it and go next. So you have here a train has an initial velocity of 44 meter per second and accelerate of negative 4 meter per second. Now its velocity after 10 seconds what? So you can see now it actually have an initial velocity of 44, but its acceleration, this uniform velocity, its acceleration is negative 4. So if you see this, it actually tell you that it's retardation. I tell you, you don't need to put r, just put it as negative a there, right? So that's cool. So you should find the final velocity when which is unknown when the time is 10 seconds there. So what we are not giving is actually s. We're not giving s. Which question is actually the first one? Walk u plus a t. Now here we have minus there, right? So we use minus 80. So final velocity is equals to initial velocity as 44. Now minus 4 times the t there is 10. So you have a final velocity is equals to 44 minus 40. So final velocity is just simply 4 meter per second there, right? So you can see that the final velocity is smaller because the thing is reducing speed there. So that makes option B the right answer there. So now let's go to another one. Nice question. So here you say if it takes an object 3 seconds to fall free to the ground from a certain height. This free fall there, right? What is the distance covered? So we say something fall from certain tree there, right? They didn't say they throw the thing, they didn't say they push the thing fall. So actually before you start falling, you start from 0. So always remember how you're going to put this. Remember how to bring out this data. It's very important. So it falls, free fall, always start from 0. And it takes a time of what? 3 seconds to fall to this ground there, right? So what the distance cover? What's the height they are asking you to find there, right? What's the height? So when you're talking of free fall, acceleration is always a bonus answer there, right? And it's now acceleration due to gravity, which is always 10 meter per second square if you want to approximate. But when you're dealing with higher exams, you need to use 9.8 like that. But for our case, a Jamb, other things, use 10 to make it easy. So now you're giving all of these things, you're not giving v. Actually, in free fall, acceleration is replaced by g and the distance is replaced by h. So this is the same thing as the distance there. So it's always velocity that we don't have. So we can use the second equation, which is s is equals to ut plus half at square. So in this case we're using h. H is equals to ut plus half g now t square. So h is what we are asked to look for. So h is equals to the u there is 0 multiplied by the time there is 3 plus half times 10 times 3 square. So all of these things will be 0 there, right? And 3 square is what? This divided by this 5. 3 square is actually 9. So 9 times 5 is 45 meter. That's the height you get. So that makes option C the right answer for that. Very, very simple to get it. As I say, it's all about data, right? It's all about data. Once your data is cool, once your data is fine, formula is easy to grab, and the rest is just math. So now, next is calculate the total distance covered by a train before start coming to rest. So it's now coming to rest. telling you that final velocity is what? 0. Please, I think this thing is easy. So coming to rest. So if its initial velocity is what? Is 30. So with a constant retardation, they tell you constant retardation. So you put A is equals to negative 0.1. Remember, retardation is negative, acceleration is negative 0.1. So you're asked to calculate the total distance, that's S is equals to unknown. So now we're not giving, actually we're not giving time. So in this case, we're going to use the fourth one, which most people don't. Yeah, okay, we're not giving, no, not this one. We're going to use the third one. Yeah, because that one, that acceleration was not given, which is v square is equals to u square plus 2as, right? So that's the equation. So final velocity is actually 0, which is equals to initial velocity is 30. So you have 30 square. So now you have plus 2, and your acceleration is now negative 0.1, close bracket, multiplied by the distance what you're looking for. So your left is 0 is equals to 30 times 30. Let me break it down, which is equals to 9 and 0, 0. Now here we have negative, so this will turn minus 0.2s. Well, it's cool. So if you take this one to this side, you have 0.2 this, and you divide also by it, you have s is equals to 900 divided by 0.2, right? And 900 divided by 2 is actually, let me say 90 divided by 2 is 45, and the other 0 is there. That's the other 0 that I kept. And if you take the other 0 here up to give you another one, you can just place 900 divided by 2, you get your answer. So you have 4,500 meter as B is the right answer. I'm using hand to do it, that's why it's causing me like this, right? Use your calculator to get it fast. If you don't want to use calculator, you follow me. So that's B is the right answer for that. Now let's go to next question. We're moving. Hope you understanding and following. So a car starts from rest. Everyday rest, no rest. So start from rest, so u is equals to 0. With a uniform acceleration of this starting and for a time of 20 seconds there, right? Calculate the distance covered at the end of the motion. So the total distance you are asked to calculate there, right? I love this question because this question really hit it down very well. So we are not giving v, right? We are not giving v, so we can use the second one, which is say s is equals to ut plus half at square. So s is equals to u is at 0, so multiplied by 20 and plus half. A is what? A is 30 multiplied by t is what? 20 and the square of it. So all of this one is actually 0, so you have s is equals to 0 plus. Here you have half multiplied by this, or let me cancel the half with the one of the two here. Let's go gradually. Half multiplied by 30 multiplied by 20. 20 squared is actually 400. So you have this here remain 2, and 2 multiplied by this is actually 6, and all of these zeros there. So you have 3 number 1, 2, 3. And actually this is always in meter. So distance is measured in meter, but in this case we have 6,000, but and all of our units here are in kilometer. So to convert meter to kilometer, you actually divide it by 1,000, where all these zeros will go, you left with 6 kilometer. That's the right answer. So you should also know how to convert. It's not always know how to solve, but sometimes you solve and you still fail because of your unit. That's cool. So now let's go to next question here. Here you have a bus. So a bus travel at this at so it's traveling at that. So that's the initial velocity, right? We start this our case with this bus when it was actually traveling at 15. So that's the initial velocity. So and accelerate at this at 4, right? Meter per second square. So what is the distance cover in 10 seconds? So now asking the distance cover when the thing move in time of 10 seconds. You're also not given v, so you can still use the last equation, ut plus half at squared. So that's the distance we are asked to calculate. So now we are given as velocity, we are given the initial velocity, so it's not 0 there. So you have 15 multiplied by 10 plus half multiplied by a, which is 4, multiplied by t squared, which is 10 squared. So 15 squared is actually 15, 0 as 150, and plus these two here will go remain 2, and here you have 100, so 2 times 100 is just 200. So if you add this, you have 350 meters. That's the distance it covers, which makes option C the right answer for each. Very simple and clear. Now let's go to the next one. Relay smashing. So here you have this question. Let's say this is a bonus question. So let's say a body with an initial velocity u accelerates onto it attain a velocity v, that's the final velocity. Now within a time t. So the distance cover that this body is express is what? Well, I wrote the final question, the fourth equations there, right? If you remember, I wrote it. But you can drive it very easy by knowing that the total distance is just average velocity multiplied by time. Average velocity. Make sure you remember average velocity. And in velocity, we are dealing with initial and final. We are dealing with two things there, right? So the average velocity is actually when you want to get the average velocity from initial and final. You know everything. If you want to take an average, you add all of them and divide it by their numbers, right? So we add final and the initial there, right? Now we're going to divide it by their numbers, and the numbers is their twin number. So v plus u all over t all over 2. That's it. So from that you have your distance is equals to v plus u all over 2 multiplied by t. Or you can use brackets to do it, but and you get something like this. So v plus u all over t, and the right answer is actually option C there, right? Because this thing is actually an acceleration. That's what makes option C the correct answer. Option A is wrong because it's not negative, it's actually plus. When we're taking average, we add. So what is it? You don't just jump in and just tick the wrong answer. Pay attention and get the simple question that you know correct. Don't let confusion or get in hurry and fail the simple ones. So here you have the final question we have here is that an object falls freely from a height of 45 meter onto a roof of a building 8 meter high. Calculate the velocity with which it strike the roof. So fall freely, telling you that initial velocity was 0, fall from a height of this onto a roof of a building. So this is what happened. So this thing is falling from here and it falls to a roof of this house. So fall to a roof of this house there, and the roof from this house is actually what? It's actually 5 meter high, and this thing is actually 25 meter high when it's coming down. So the real distance that this guy moves is actually from here to here. You can see it very clear. So from here to here, since from total is 20, and if you minus this 5, you will be left with 20 meter. So that's the distance this thing travel, or the height at which it falls there, right? Height as 20. But you should know how to interpret question, which is very, very important, because if you don't know, you won't know which one to use as height. Thank you. So let's go next. Is that calculate the velocity? They're asking the velocity, which is unknown, and it's like that's the final velocity, while g is giving us 10 meter per second square. So which one to use? We're not giving time, so we should neglect a question that has to do with time. And well, the third one will work there, right? V square is equals to u square plus 2 as. But here is in terms of free fall, so we are using v square is equals to u square plus 2gh. So v square is actually what we are looking for. Is equals to u square, which is 0 plus 2 times 10 times now here 20 for the height there. So v square is equals to, here you have 400. So if you take square root of both sides, you're left with what? 20 meter per second square. So 20 meter per second. Actually, this their option should be 20 meter per second, 1 not 2 2, right? Some people say if you meet this kind of question, you should skip it because there is no answer. But while if you skip it, sometimes they wrong you, because they actually sometimes computers say that is typing error, so they will still mark it. I don't know which one to advise, but me in my exam, that's me, right? I used to pick it. The best one, because I heard somebody saying there's no any jam question that is wrong. Although everybody know that there's wrong question. So this computer that is marking, computer won't say that this thing is wrong. It's what they give the computer will mark. If it is before, they can add you mark, or they will say negative mark or that thing. But this one is computer as mark. So I just prefer just ticking it there, right? Just taking the closest answer, most especially here that is just the unit that fuck up. So you just go with it, no doubt. If you choose to leave it blank, well, you pray everything will be fine. So that's all for this topic. It's very, very simple and clear. And make sure you calm down and repeat. Look for other questions and see how you're going to be solved. As I said from the beginning, it's all about removing your data. If you get your data, the rest is just inside it inside the formula. Because to know the formula is very easy, just like you say. But especially if you are used with the formula or you've crammed it. Right now, if you're not yet cool with the formula, you can be checking the formula. Anytime you write, you bring out your data. Now check among the formulas. Let's check which one is good for me to use, which one there is no what I'm not having in my data. So that's how you use and get it fine. So without waste of time, waste of energy again, this is the end of the video, right? So make sure you really practice how to help yourself. Thank you so much.